EE452 Design Project. Basic robotic programming using C++ language. Team members are Stephen Roskins, Carissa Gonzalez, Bruce Burris, Christopher Turner, and myself, Dave Rivera. I'll be using the Arduino AT-MEG32P processing in conjunction with the Board of Electronics Shield, the Parallax board, which will allow me to drive the robotic controls, the servo controllers. The servos, I had to pre-adjust the servos using these potentiometer pods so I can tune them so that when we download the programs it does not run amok. I will be discussing not only the robotics, the hardware, but also the software that controls it. We'll be using the Arduino software. It's a basic C++ language, and the purpose of this is to show basic programming by moving the robot forward. We're going to circle left, then circle right, and then come back to its home position. I programmed it so that it will extend beyond the home position just by a few inches. That's a couple of nanoseconds, or microseconds further. The Arduino programming allows us to program basic C++ programs. In here, the robotic movement is forward, circle left, circle right, then backwards. It's all based on time events. We'll use the left and right servos for this movement. The left servo will move a certain increment in delay in time, and then also the right will also move it simultaneously for a different increment with a delay in time. Those times I just selected because of the limited space that I have downstairs in my workshop. Now I'm going to program the Parallax robot. Now I'm going to program the Parallax robotic controller. I'm going to plug in and ensure that the device is off. To assist me in programming, the parallel outputs are on the shield board of pins 12 and 13. I have placed two 220 ohm resistors, and then 2.3 volt LEDs to a ground circuit already provided on the board itself. I am going to compile this program and verify that the compiling contains no errors and that the compiling is complete. I have done compiling with a binary sketch size of 294 bytes, and it has a maximum of 32,256 bytes. Now I will upload the program into the Arduino. And as you can see with the red lights, it is uploading the program, and when the lights are distinguished, we will be finished programming. I will disconnect it, and now I will test it. To test it, I'm going to reset and place it in position 2, release. It initializes, it'll move forward, turn to the left, turn to the right, and return backwards. As I indicated earlier, I programmed it for a little bit longer, and it has surpassed its home position by just a few inches. I'm going to repeat this by just hitting the reset button. It initializes, moves forward, to the left, to the right, and backwards. And that concludes this period of demonstration.